Hey Mustangs, in this video I'm going to teach you how to solve a Punnett square for X-linked gene disorders. Now it's a little bit different than solving a normal Punnett square, so make sure you pay close attention and don't assume that you know how to solve these. Alright, so in order to do this you're going to need your handout for X-linked gene disorders, and we're going to jump right in and do the top portion in order to fully understand what's going on with solving a Punnett square for X-linked gene disorders. So the top portion of the handout looks like this. So it says X-linked gene disorders are rare in females but often common in males. So this top portion of the handout is going to help you get some important background and knowledge in order to fully understand these types of disorders. So what I'd like you to do is underline the portion where it says are rare in females but often common in males. Okay, so we're going to see why exactly that is. So it says for genes found only on the X chromosome, this does not apply to the autosomes, females XX have 2 copies of each gene. They get one from mom, one from dad. So if we're looking at the X's, one of these X's came from mom, the other X came from dad. Males have 1 copy of each gene. When we look at this, the X, remember, always comes from mom, the Y always comes from dad for a male. So males, when we're talking about the X chromosome, the X and Y are not a homologous pair. So every gene you find in the X is not found in the Y and vice versa. So here, they only get 1 copy of every gene. This is why males are more likely to have these disorders than females. It's more common in them than females. It's pretty rare for females to have these disorders. Females get a second chance. So if they get a messed up gene from one parent, they have a second chance for it to be covered up because most of these disorders are actually recessive. Males, on the other hand, they have 1 chance and 1 chance only. Another important bit of information that you must know is that when we look at a female, females can be normal, they can be carriers, or they can be diseased. So right here, a female XX is a carrier if they are normal, but carry the gene. So it's going to look like this. So go ahead and circle this. Put a star here. Okay. Whenever you see a female who has a normal allele with a recessive mutated allele, they are normal because normal is dominant over the recessive disorder here, but they can carry it and pass it on. So that's really, really important to remember. A female is only considered a carrier if she's big N, little n, if she's heterozygous. This female is not considered a carrier. She actually has the disorder, so that is not a carrier. Only this is a carrier. All right, now as you solve the problems down below, you're going to want to refer to this part of the handout here where it says big N is normal, little n hemophilia. I used N throughout this whole handout so that way we can just stay consistent. Big N normal, little n night blindness. So you just got to keep referring back up here to whatever the handout is talking about. Alright, so let's go ahead and solve a Punnett square for an X-linked disorder. So it says solve numbers 1 and 2 for the disorder hemophilia. So if I go back real quick and I refer to the top portion of the handout, big N is normal, little n is hemophilia in this case. So first thing, we want to write down what each thing means just for a reference. That way we could refer back to this. So big N will be normal. Little n would be hemophilia. So we're going to be given the parents' genotypes. So we know this is the mom, XX, this is the Y, this is the dad, XY. So the mom, she's X big N, X big N. We look here, big N, even though we're going to be using the same letters, that's why it's important to refer up here. You got to pay attention up here. We know that big N is normal, so the mom's phenotype is going to be normal. We look at the dad, X little n Y. Little n is hemophilia, so the dad has hemophilia. Okay. Now, when we set up the Punnett square, it's pretty much the same way that we normally set up a Punnett square. with the slight difference is that we have to take the X's and the Y's with the alleles that we're referring to. So I'm going to do what we usually do. So I'm going to put a circle with the arrow to follow the male, the dad's information, the circle with the plus underneath for the moms. So the dad, we have X little n Y. The mom is X big N, X big N. When we fill in the Punnett squares, do it the same way you usually do, because we haven't got to that difference yet. So we got X big N, X little n, X big N, Y, as this and this came together. This one and this one will come together in this box here, so X big N, X little n. And finally this one and this one will come together in this box, X big N, Y. Okay? So we have our Punnett square filled in. Now we can't treat it the same way we usually treat a Punnett square and say each box is worth 25%, because what we're looking at here is this half right here, these represent the daughters that they're going to have. This half over here represents the sons that they're going to have. So we can't look at it as a whole complete Punnett square in that way. We have to look at it as daughters versus sons, and that's how we'll ask our questions and answer our questions as well. So how many daughters have hemophilia? So we cover up. I usually use my hand to show this, but you'd cover up the sons and just look at the daughters. So look at these two. How many daughters have hemophilia? Well, we have a big N, little n, that's normal. Big N, little n, that's normal. So 0 daughters have hemophilia. How many daughters are carriers? Now remember, a carrier is normal, but they carry the messed up allele. So we look here, she is a carrier, she's a carrier. So we have 2 that are carriers. And finally, how many sons have hemophilia? We look over here, X big N, that's normal. And X big N, that's normal. So 0 sons in this case have hemophilia. So that's what you do each time you do a Punnett square for an X-linked disorder. Make sure to look at one half of the Punnett square at a time, daughters versus sons, not the whole thing.